Hello everyone. So let's start solving today's problem. Delete middle element of a stack. And in this problem, all we have to do is to delete the middle element of the stack without using any additional space. So we have to solve it using recursion and algorithm. So what we have to do is, as you can see, if there are 5 elements, the middle one is 30, right? So the 30 gets deleted and we have to return. All we have to do is to make the changes in the stack. We don't need to return anything. And in the second test case, if you look, we get to see 1, 2, 3, 4. So second element is, so 4 divided by 2, middle element should be this 20, right? So this 20 gets eliminated. So what I'm going to do is, so if you look at the expected space complexity, they have written big O of n, right? So do not misunderstand that. We don't need to use any vector or anything or another stack. This space is for the recursion stack space, right? Recursion takes a stack for the function return call. So that's why they have given big O n. We don't need to, as they have clearly specified, we don't need to use any extra space. So what I'm going to do is, first I will place, so I've already written the very first test case. So let's visualize it through a stack. So the 10 would be here, 20, 30, 40, and 50, right? So initially the top pointer is here at 50. All right. So what I'm going to do is, until I reach this middle element, which is nothing but stack space divided by 2. S, suppose let S denote the stack space. So S divided by 2 is the where the middle element is placed. So until I reach this S by 2 position, I will keep on eliminating. But here's a catch. We have to again insert the popped element, right? We don't need to delete any other element other than the middle one. So we again have to push it into the stack like this 40 and 50. We can't simply eliminate them. So what we can do is, first we will call the recursion until we reach the s by 2th position. All right. And once we reach the s by 2th position, we simply pop this element and return. So while returning, we will be having these 40 and the elements above the middle element placed in our variable, right? And then we again push it into our stack. All right, so let's start solving this problem. So let me first initialize a count variable here. Otherwise, while calling the recursion, it would again be initialized with 0 again and again. So if my count reaches size of stack divided by 2, then what I have to do? I have to simply pop that middle element. So first pop and then return. All right. Okay. Now in the else part, what if our count is not on the size of stack position? So first what we have to do is take the popped element, suppose in the x variable, s dot pop. So I've took out 50 now and placed it into x. Now I will increment my count because I have I have shifted towards the middle element, right? So I have increased my count, and now what I'm going to do is call the recursion. All right. And then after returning, I will simply push that element into my stack again. All right. So let's check if this code works. Okay, s dot pop. What's wrong? Okay, pop doesn't give me the element. So I need to do. I will pick the topmost element and then I will pop it, right? My bad, I just forgot. All right. Thank you.